Hello, and welcome back to part 3 of our AOS8 Essential RF and Client Troubleshooting Techniques. I realized in the first 2 parts I completely overlooked the data rates, which are super important for any healthy wireless network. So we're just going to take a couple minutes and get over that. In this one, we will start with the UI here, just to show you where to find the data rates. So here on the main dashboard, we need to get into our proper configuration section, and we'll pick on the campus here. Configuration. And we'll notice that under WLANs, which is where we define data rates, you can't actually adjust the data rates through the WLAN wizard. You cannot use this. So if you're using the WLAN wizard to create your networks, your data rates are probably all at the lowest rates, which is not desirable. Unless, of course, you've gone in and tweaked them afterwards. Where we really want to look is under the system profiles, wireless LAN, and under wireless LAN, they're all configured under the SSID. So under the SSID here, because they're all configured individually separate. See here, I got a lot of goofy testing I've been doing here, but if I pick one, I can scroll down, scroll over, scroll, I guess I'm going to try to scroll over here. Okay, so here are our data rate settings right here. So we've got basic rate and transmit rates. So basically what the basic rates are, are the minimum rate that a client must support in order to associate to the WLAN. So in this case, we have trimmed some of the basic data rates. Let's look at one that's not configured properly. Here's one that has the default settings. So basically what we see here is that the client has to only be able to support the lowest data rates in order to associate to the WLAN. But this isn't a good thing. That means that the client can associate to the WLAN that's the most basic data rates. And these basic data rates mean that it can talk really slow. Not can, it will talk really slow if it's running at these lower ones. And if you recall from general Wi-Fi principles, only one client can talk on a channel at a time, with some exceptions with multi-user MIMO and things like that. But for the majority of the clients, only one client can talk at a time. So if you got somebody talking really slow, you got to wait for that guy to finish his transmission before somebody at a higher data rate can take the transmission opportunity. This also means that a client can hang on for a very long distance because these data rates are big blobs in the air. You could discern 1 megabit from a very long ways away from the AP, quarter mile maybe. And you never ever want a client hanging on like that. It should have roamed. You should have enough APs in your environment to allow the client to make a decision to roam. So we can do things to the environment to help that out, to not allow that to happen. It's called data rate trimming. As we trim data rates, now we're saying, hey, the management frames are going to go out at 12 megabit. You're not even going to see management frames at these lower data rates. So there's 2 different bands here. This is 5 gigahertz. This is 2.4 gigahertz. So we've trimmed this so that the management frames are only going out at 12 megabit, but they could still use these other data rates. So we trim these as well. Now we're saying that a client can't, on either of these bands, communicate at these much, much slower data rates. And this is a good thing. In environments where you have a good dense deployment of APs, you're not just basic coverage, you actually have designed for capacity, meaning that you want to make sure that the clients have enough APs to support the clients and to support the capacity that's needed, meaning they can get on and off the AP as quickly as possible. If you have a dense enough environment, we can even do something like trim it a little bit more. So we don't even have to have 12 enabled here. So we can do something like that. So that's data rate trimming. That's how you do it for an SSID. You want to do this on all your SSIDs, right? Because remember, a channel, and I say remember as if we've gone over wireless basics, and maybe I'll do a video on that at some point in time, but on a channel that an AP is operating on, all those SSIDs are using that channel. So if you have one SSID that has all these lower data rates enabled and another SSID that doesn't, the channel's still suffering. Even these faster guys still have to wait on the other SSID that's configured for 1 megabit for that client to get on and off really quick. So when you adjust these, you want to adjust these across all your SSIDs. Okay, so that's how we see that from the UI standpoint. And jumping over to the CLI, looking at the same controller here, we can take a look at the configuration by SSID profile. Here's all my profiles. So if I were to pick one here, what was the one we just looked at here that was not configured correctly? I think it was that one. Yeah, so we could see that this guy has all of its basic rates, all the minimum, slowest rates still enabled. If we were to look at one that is properly configured, just pick another one here. There we are. So this is a properly configured SSID with data rates trimmed. And note here that the G, so this is 2.4 gigahertz, I still have 11 enabled, and that's there in case you have some really old legacy clients. So the 802.11b standard said that the fastest data rate that 802.11b could modulate with is 11 megabits. So really, you want this turned off too. I don't know why I have it turned on. There's very few environments out there that have 802.11b only clients. I mean, they have to be, 10, 15 years old. So usually we want to trim those off as well. Feel free to leave some comments. Let me know other things that you might want to see either in the controllers. Are you interested in seeing how we do this in Aruba Central, AOS10, instant APs? Do we want to go over Wi-Fi primer? Any of those things. But yeah, just leave some comments. Let me know. Reach out directly.